This is a video from section 11.10. Recall, e to the x is equal to the summation from n equals 0 to infinity of x to the n divided by n factorial. The radius of convergence is infinity. Cosine x. This is the summation from n equals 0 to infinity of, you're going to get negative 1 to the n divided by 2n factorial times x to the 2n. The radius of convergence is also infinity. Sine of x. This is equal to the summation from n equals 0 to infinity of, we're going to get negative 1 to the n divided by 2n plus 1 factorial times x to the 2n plus 1. And the radius of convergence for this series is infinity. There's a couple more things I want to go over. Now, 1 over 1 plus x. This is the summation from n equals 0 to infinity of negative 1 to the n, x to the n. And if you guys remember, x is between negative 1 and 1. And so, of course, the radius of convergence is 1. Now, natural log of 1 plus x. This is going to be equal to the summation from n equals 0 to infinity of negative 1 to the n, x to the n plus 1 divided by n plus 1. And the radius of convergence for this series is also going to equal 1. Now, with that in mind, I want to do the following. It says, find the function represented by the given power series. Now, with that, I want to take a look at number 79. Now, here's the series that I want to get a handle on. It's the summation from n equals 0 to infinity of negative 1 to the n, x to the 4n, divided by n factorial. Now, this is the summation from n equals 0 to infinity of negative 1 to the n, x to the 4th raised to the n, divided by n factorial, right? Now, let's take a slight step back. Remember that e to the x is the summation from n equals 0 to infinity of x to the n divided by n factorial, right? Now, if I take e to the negative x, this is the summation from n equals 0 to infinity of negative 1 to the n, x to the n, divided by n factorial, right? And then what I can do is replace x with x to the 4th. And when I do that, I get e to the negative x to the 4th is the summation from n equals 0 to infinity of negative 1 to the n, x to the fourth raised to the n, divided by n factorial. And if I simplify this a little bit, this is the summation from n equals 0 to infinity of negative 1 to the n x to the 4n divided by n factorial. And that's exactly what I wanted. And so the correct answer here will be e to the negative x to the fourth. Now, let's take a look at 81. Now, on problem 81, we have the summation from n equals 0 to infinity of negative 1 to the n, and then this is times x to the 2n plus 1 divided by 2 to the 2n plus 1 times 2n plus 1. Like so. Now, there's a couple things we need to take a look at. Now, I'm going to write this as the summation from n equals 0 to infinity of negative 1 to the n times. Now, I'm going to get x over 2 raised to the 2n plus 1, and I'm going to take that and I'm going to divide by 2n plus 1. Okay, from here I want to introduce you to one more series, and that's the following. It's arctangent x is the summation from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 divided by 2n plus 1. So this is something we can derive at the end of this video if we need to. Now, look at here. So I would say we're pretty close. So remember that arctangent x is the summation from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 divided by 2n plus 1. And then all I have to do up here is just replace x with x over 2. And so therefore, arctangent of x over 2 is the summation from n equals 0 to infinity of negative 1 to the n times x over 2 to the 2n plus 1 divided by 2n plus 1. And if I go to simplify that, you can see that I'm going to get my desired result. This is the summation from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 divided by 2 to the 2n plus 1 times 2n plus 1. And that's how we do number 81. And that's, of course, the formula for arctangent x. And what if I ask you the following? It's to find the sum of the series. And with that, we're going to take a look at 83. Suppose we have the summation from n equals 0 to infinity of negative 1 to the n over n factorial. Now, let's not overcomplicate this one, because check this out. Remember that e to the x is the summation from n equals 0 to infinity of x to the n over n factorial. So, and by the way, this is true for all x. So I could easily put in -1. And so e to the -1 is the summation from n equals 0 to infinity of -1 to the n over n factorial. So you're evaluating a function for a specific value of x. In this case, it's -1. And that's exactly what I wanted. So the correct answer here is e to the -1. Let's take a look at 84. On 84, we have the summation from n equals 0 to infinity of -1 to the n pi to the 2n divided by 6 to the 2n times 2n factorial. Right off the get-go, you should be thinking of the cosine function. Because, check this out. Cosine of x is the summation from n equals 0 to infinity of -1 to the n x to the 2n divided by 2n factorial. And I'm going to pay attention to pi to the 2n over pi, I'm going to pay attention to pi to the 2n over 6 to the 2n. Because now, look, cosine of pi over 6 is the summation from n equals 0 to infinity of -1 to the n times pi over 6 to the 2n divided by 2n factorial, right? But can't I write this as the summation from n equals 0 to infinity of -1 to the n pi to the 2n divided by 6 to the 2n times 2n factorial? It's just laws of exponents. And so correct answer here is cosine pi over 6, and cosine of pi over 6 is square root of 3 divided by 2. That's how we do 84. Let's take a look at 86. On 86, we have the summation from n equals 0 to infinity of 3 to the n over 5 to the n times n factorial. Now, I think of e to the x because that's the summation from n equals 0 to infinity of x to the n over n factorial. And then I'm looking at 3 to the n over 5 to the n. So now isn't 3 to the n over 5 to the n 3 over 5 to the n? So what if I replace x with 3/5? So you get e to the 3/5 is the summation from n equals 0 to infinity of 3/5 to the n divided by n factorial. But most certainly, this is the summation from n equals 0 to infinity of 3 to the n over 5 to the n times n factorial. So the correct answer here for 86 is e to the 3/5. It's a good question, finding the sum. And notice you're adding up an infinite number of rational numbers and getting an irrational number back, which seems very, very counterintuitive. But that's what's happening here. Let's take a look at 87. So 87 is the summation from n equals 0 to infinity of -1 to the n pi to the 2n plus 1 divided by 4 to the 2n plus 1 times 2n plus 1 factorial. Okay. Notice the odd exponent. And so we should be thinking of sine of x. So this is the summation from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1, divided by 2n plus 1 factorial. So if we really watch this, I'm watching pi to the 2n plus 1 divided by 4 to the 2n plus 1. Because remember, pi to the 2n plus 1 divided by 4 to the 2n plus 1 is pi over 4 to the 2n plus 1. So if we notice, sine of pi over 4 is the summation from n equals 0 to infinity of negative 1 to the n times pi over 4 to the 2n plus 1 divided by 2n plus 1 factorial, right? But I can simply write this as the summation from n equals 0 to infinity of negative 1 to the n pi to the 2n plus 1 divided by 4 to the 2n plus 1 times 2n plus 1 factorial. And that's what I wanted, right? And keep in mind, sine of pi over 4 is square root of 2 divided by 2. So the correct answer to problem 87 is square root of 2 divided by 2. And let's do one more for this video. And I want to take a look at problem number 89. So on 89, we have 3 plus 9 over 2 factorial plus 27 over 3 factorial plus 81 over 4 factorial. And we keep going in this pattern. You want to write this using summation notation. It's just more advantageous to do that. And so this is the summation from n equals, we're going to go 1 to infinity, okay? So this is the summation from n equal 1 to infinity of, now remember, 3 equals 3 to the first. 9 equals 3 squared. 27 equals 3 cubed. In all of these videos, I'm stressing to put things in factored form, okay? So this is going to be 3 to the n divided by n factorial, like this. Now, this one's really, really tricky, and we have to be careful, okay? Why? Because if we look at e to the x, this is the summation from n equals 0 to infinity of x to the n over n factorial, right? It looks good, right? And it looks close. Now, we can agree that e to the third is the summation from n equals 0 to infinity of 3 to the n over n factorial. But I would also pose the question, is that correct? And in short, the answer is no, right? Because I can let n be 0 and get 1, and then I could add the summation from n equal 1 to infinity of 3 to the n over n factorial. But if I solve for this, piece, I'm basically going to get e to the third minus 1. we really have to pay attention to that lower limit. I can't stress that enough, right? So in fact, the correct answer here should be e to the third minus 1. That is an outstanding question that I would encourage you to really take a look at. Yeah. So that'll conclude this video for section 11.10. And in this video, we took a look at problem 79, problem 81, 83, 84. We took a look at 86, and we took a look at 87, and then we took a look at number 89. So, okay, thank you.